Hello and welcome to LeetCode 547, number of provinces. This is quite an easy problem. It starts it goes like this. There are a number of cities. Some of them are connected while some are not. If city A is connected to city B, then if city B is connected to city C, this means that city A is connected to city C indirectly. So we want to count the number of provinces, which is like all the cities that are connected either directly or indirectly form a province. And we want to count the number of provinces. So we basically are giving some sort of a lot of graphs. We gotta count how many graphs are in this span of graphs or whatever, in this span tree, whatever. And well, as you can see, this is like one of the examples they give you. This is quite simple. So this is connected graph tells us what cities are connected to which cities. So for index 0, this means for city 0, city 0 is connected to itself. It's also connected to city 1, and it's not connected to city 2. Same for city 1, it's connected to city 0, it's connected to city 1, which is itself. But it's not connected to city 2. However, city 2 it's on its own, so it's not connected to any of graph city 0 or city 1, but it's of course connected to itself. This will mean that there is 2 provinces for this particular case. Now let's look at a more complex example. So let's take a look at a more complex example. Here's let's take a look for this matrix. So series 0 is connected to series 0, city 1, and that's it. City 1, however, is connected to series 0, 1, and 2, but it's not connected to the rest, and so on. You can make this graph from this list. And well, the way to check this is just once we build the graph, which will be the first step once we start coding, we can just sort of try performing any searching algorithm on starting on every node. Call it depth first search or breadth first search. You can even do union find. But that's a little bit more complicated. Let's just do depth first search. So if we start like for a series 0, then we will basically visit all these nodes, and by the time we start visiting we go to the next iteration and try visit all the nodes starting at node 1. We will have all of these nodes already added to our global visited list. So we will just skip it, then skip 2 as well until we get to iteration 3, starting at 3. And then we will add all of these nodes through depth first search to our graph. And same for and so on until we go to number 5, which it's just like it's just alone on its own. And so time complexity for this, it's gonna be n squared. It's gonna be the time we will take to build our graph. We can actually perform depth first search on all nodes on time of n, but the time it will take for us to build the graph, it's gonna be n of 1, because imagine the case where we have a fully connected graph. Then basically we have to visit all this connected matrix with shift size of n times n, which gives us a complexity of L of n squared. As for the complexity of the space, this is also O of n squared for this particular case. However, we could just use this matrix to perform the depth first search. However, I find that a little bit more complicated, and space is generally not as penalized as time. So let's just build our connected graph, which will basically be the same size as this. It can be as large as this, but it is easier to use. Yeah. Let's get into the code. Well, before heading to the code, if you really want to know the space complexity, it's just the visited nodes, which is as of n since g of our graph is just gonna be some subsidiary. We could basically not use it, but it's easier to just build the graph. Alright, so let's get right into the coding. So first things first, let's build a graph that will tell us the number of this will tell us which cities are connected to each city, and I'll just put n here because I might use that a few times, which is the size of the number of cities. In order to build this graph, we will just visit each node and see which cities it's connected to. In order to do this, we can start with an empty list for every node, and then visiting all the other cities. We know that this is connected graph tell us if I is connected to j, if the value is equal to 1, and since we don't want to connect the city to itself, we also want to make sure that we're not visiting the same index. I mean, I think you could do it and it wouldn't matter because we're gonna put this node in our global visited list anyways, but this just keeps it cleaner. So now we're just gonna define our depth first search. For this occasion, we only need 2 parameters: the node we're visiting and the scene list. Now, if our node is already non-scene list, we just return. There is no point in performing the first search anymore. And if, in order to prevent a recursive loop, we add this node to our scene list if we're about to perform the visiting of every neighbor. To get the neighbors, we just check our dictionary graph stuff. And well, this will give you like the neighbors, and we can extract for the neighbors, performing the first search. So we perform the first search for every neighbor, and this will recursively add all like this isolated graph or province, starting on whichever node. It doesn't matter which one we visit first, since it is a bidirectional graph. So let's build our global visited list, and we need a counter for number of provinces, and we're also gonna keep track of the last graph size to know if our last scene size, let's just call it like that, it's a little more intuitive. So at the beginning, this is 0 because visited is an empty set, but this will change quick. So we will try to we will start iterating beginning at every node, and on every node we perform the first search. This will add all like these province or graph to our visited list, and we want to check like we want to check if our visited set incremented. This will mean that we visited a new graph. And if that's the case, then we know we have one more province. The province is plus equal 1. And we also want to update our last scene size of this, so that we know that basically this makes sense. Otherwise, we will just keep going here every time. Yeah. And I mean, this should probably work. But also, let's just avoid the last case, like one of the worst cases where it is just one province, by saying if length of our visited stuff it's equal to n. This means we visited all cities already, then there is no point in keep going this depth first search. So let's try this. Seems like it works. Let's submit it. And there you go.